All right, Irene, thank you for coming on. That last panel was great.
Thank you very much, Adrian. Thank you for having me. Nice to meet you.
Of course. And you made an interesting comment about kind of making more informed decisions with our energy modeling decisions and how we're making design decisions today for the future. And you actually made the comment about weather, which is something I hadn't put a lot of thought into, which maybe it's something we need to be putting more thought into. So there had to be some aha moment or wake-up call for you where you're like, this is not accurate.
Actually, this has been a topic that I've been bringing up fairly regularly with clients. It's something that back in 2006 to 2011, I actually worked from our London office. And for part of that time, I was in the environmental physics team where we had people who were, amazing physicists and scientists working with academia to develop future, basically morphed weather data files. Mm-hmm. So I've been aware of this kind of capability for quite some time now. And it's been developed into WeatherShift, which is something that Arup has offered. And every weather file, it doesn't even cost that much to purchase these morphed weather data files, but it just makes our building designs that much more accurate. When I started at Arup, one of my first projects was energy modeling for an existing building. So I basically had to try to calibrate the energy model to existing utility data, which was very fascinating. And I just know that if we don't use accurate weather data, that, when we're designing a new building, it's going to be occupied in the future, not in the past.
Sure, yeah.
So designing with historical weather data doesn't actually make sense. You're starting off with the wrong assumptions to begin with.
So because you're in LA in such a moderate climate zone, instead of extremes like the Northeast or in a hurricane zone or even here in the Pacific Northwest, are your projects really widespread? There's a lot of supply in California.
Yes. So actually, our team covers what we call the America's West geography. So we do a lot of projects in the Pacific Northwest. We do a lot of projects in California, but we also work with clients who have international projects. So every time we start on a new project, it's fun for me to just look at the climate data, look at what the trends are. Like, is this a heating dominated building? Is this a cooling dominated building? What is the building typology? What are the primary design drivers that we can help control or optimize? And
what are the big variables that really move the needle? Are we talking about like solar patterns, like warmer summers, colder winters? What's really driving design decisions?
Solar patterns, I think, are not shifting as much. It's usually warmer, hotter summers. It depends on the specific location as well. Sometimes it's colder, wetter winters. Sometimes it's a bit of both. But overall, there's actually much more humidity in the air. And so we're seeing much more extreme storm systems. Water is a great moderator of temperature. And so actually a lot of the global warming has been absorbed in our ocean. So ocean, water temperatures have actually increased a lot more than ambient air temperatures. And so I think just that it's not just temperature, but it's also enthalpy, right? It's like that different balance in the water cycle. My background is actually in environmental engineering in California, where I studied water in my undergrad and grad school. And I just happened to kind of fall into energy efficient buildings.
Yeah, this is not something, and might sound misinformed by asking the wrong questions, but if you think about, like you just said, more moist air or like wind-driven rain, if storms are getting more extreme, how do design pressures and wind loads factor into this, and understanding how the facade is going to behave under those extreme conditions and keeping the envelope weather tight?
I think we already saw some of that with Superstorm Sandy, where I don't think New York was necessarily expecting such extreme storms, but the hazard maps are actually shifting, and we also need to, not only do we need to be modeling our energy use, thermal comfort with future morphed weather data. We also need to be tracking what the hazard maps look like, just like what does the hurricane risk look like.
So I'm gonna throw a wild question out there that I haven't asked before, but energy codes become more and more stringent. Maybe British Columbia is the most extreme. I'm in the Northeast, so I'm accustomed to Boston, which is very extreme. Then you really ratchet down from New York to DC, but the U value targets keep getting more stringent. And in Boston, on this podcast, I asked why the air infiltration requirements aren't becoming more stringent, but it's all revolved around energy. But why aren't we looking at it from the standpoint of design pressures and wind loads and the design pressures that the cladding is designed to withstand?
Well, we do need to look at all of that in conjunction, and that's why during the panel I mentioned, reaching across disciplines, really designing our facades holistically, because if we have a building that is energy efficient and comfortable, but it's not safe, then I don't think people will want to work in this building or live in this building, right? So, so it's really important to understand that there are many parameters, some of which have higher priorities than others. We just need to find that right balance. There are certainly trade-offs, but having that open dialogue with the owner, with the entire design team, understanding where we can compromise and where we need to kind of hold the line is really important. I've been working on a project recently where, because of cost reasons, the client doesn't want to use laminated glazing for safety purposes, but fall protection, just fully tempered, and obviously we would specify heat soak tested, but we were really pushing for laminated glass because it can serve the dual function of safety glazing and fall protection because it's a high-rise building.
I was going to say you probably exist for the most part at the apex of the performance spectrum or realm in terms of project typology, but I'm guessing the answer is no. You're probably dealing with a vast spectrum or range of projects that are design-driven, cost-driven, performance-driven, and how do we find
Absolutely. It really does depend on who our clients are. As of last year, I've been sitting on the IECC subcommittee for commercial envelopes and embodied energy. And it's funny because when we sit in on those meetings, we do have to realize that, yes, at Arup, we work on mostly high performance buildings, but those codes are designed for all buildings. And so probably roughly 90% of all buildings just follow the prescriptive code. And so we have to make sure that we accommodate for all types of buildings, different levels of sophistication, but we still need to design them in a way that meets code, whether it's safety related, energy related, but also make them high performing in terms of the user experience in as much as we can.
Well, look at the comment earlier about how if we're achieving baseline code minimums, at some point there's a diminishing return in terms of finding that balance between operational and embodied. Maybe local codes here are doing that effectively. And part of what I've been trying to figure out is these stretch codes that come into market and everyone's like, what are we going to do? And they're all scrambling. Do you think it has been effective here?
I actually personally love working on Seattle-based projects just because the code is much more forward-thinking than some other jurisdictions that I've worked in, and so it's always more fun to work on those projects where there's really more kind of building physics meat to sink my teeth into, so to speak. I know that sounds
I get it.
It makes me sound very geeky, but the only complaint that I have is that codes have pushed so much for highly insulative envelopes that sometimes there's the unintended consequence of increasing condensation risk, because a lot of the projects that I work on are curtain wall projects where we can't apply the insulation to the exterior. When we're working in a cold climate where we want where the vapor drive is from the interior to the exterior, so we want the insulation to be on the exterior of the structure or the framing. So we're limited to putting insulation on the interior, and that ends up drawing the dew point line inboard which leads to potentially increased interstitial condensation risk.
And how do you deal with that, especially in an existing building retrofit where you might be limited to interior space and have to find that balance?
Yeah, that's a great question. We haven't done too many retrofits as of now. A lot of, I guess the retrofits that we have worked on are California-based, where U factors are not as important as solar heat gain coefficients, and so in some ways we can get away with not highly insulating our buildings. But where we do need to make those considerations, we have to just ensure that the layering of the facade is appropriate. That we don't inadvertently design a double vapor control layer that can trap any interstitial moisture, that there's always one side of the assembly that it can permeate through. So selecting the right material.
And another theme is thinking about maintainability over time or adaptability, and especially when you see office to residential conversions or vice versa, in a residential type application where you have all the steam, you're cooking pasta or showering, and how are you designing the envelope and insulating in that aspect versus office where you don't deal with that at all. So that challenge of thinking through, well, are we going to need a different use for this, whether it's a hotel or what in the future, and thinking through those scenarios.
Yeah, that's a great point. I think designing for future flexibility is definitely something that we should aspire to. It's not often easy to predict what those future modifications are to a building that you're trying to design very specifically for, but that's definitely something to aspire to.
So on a closing note, because you get to work on projects globally or predominantly in the Western region, what project did you really get to sink your teeth into and you'd say you either feel like you had the biggest impact on or you're most proud of?
That's a great question. I think one of my favorite projects is actually the Amon Carter Museum in Fort Worth, Texas. I have a soft spot for existing museum buildings that need to be retrofitted. It had this east-facing main, glazed main entrance that was just being blasted by solar radiation, and obviously it's a museum, so the artwork needed to be protected. And so I got the chance to work very closely with our lighting consultant, where he, looked at mitigating light levels and UV levels, while I focused more on the thermal and solar performance, and just going on site, taking measurements. The existing frame was actually this was a building from the 1960s, but it was retrofitted in the early 90s, but the frame still wasn't thermally broken. And so with the amount of solar radiation hitting the frame, it was actually expanding and contracting so much that you could see like metal shavings on the framing. And the glass was also pillowing very significantly. So being able to work very closely with my supervisor at the time, Matt Williams, I don't know if you know Matt, but I have to give him a shout out for all the detailing. And then we had our structural engineer, Troy Zazula at the time, who did all the structural glass calcs for deflection limits, and redesigning the facade so that it wasn't pillowing, it was thermally broken, so there wasn't condensation risk. It was just a fun puzzle to solve because it had so many things that were wrong with it that we could then go in and fix.
What I'm taking from your experience is what makes a really good consultant is being able to wear the specific hat to the specific geography or climate zone, and whether it's Seattle to Fort Worth, Texas, very different requirements, different clientele, and applying first principles and building physics and trying to make the informed decisions based on that.
Absolutely.
So
it depends is the answer.
Yes. So thanks for coming on. Really nice.
Thank you for having me. Yeah, very nice to meet you too.